Hey everyone, and welcome back to the channel. Today we're diving into a real head-scratcher. When you think of earthquakes in the US, you probably picture California, right? Or maybe even the supervolcano at Yellowstone, which sounds like it should be shaking all the time. But what if I told you that in recent years, a place you'd least expect, the flat plains of Kansas, has been experiencing more earthquakes than Yellowstone? Sounds crazy, but it's true. So, why is Kansas, the land of sunflowers and wheat fields, suddenly so shaky? And what does this all mean? Stick around, because we're about to uncover the fascinating and surprising science behind the Kansas quakes. First, let's get our bearings. Yellowstone is famous for its geothermal activity. Geysers, hot springs, the whole deal. It sits on top of a massive magma chamber, a supervolcano. All that underground heat and movement definitely causes earthquakes, no doubt about it. We call these natural or tectonic earthquakes. They happen as the Earth's crust shifts and releases stress. Yellowstone gets hundreds, sometimes thousands of these small quakes every year. It's just the planet doing its thing. For most of history, Kansas was the opposite. Geologically, it was considered one of the most stable places in North America, far from the edges of tectonic plates where most of the action happens. A significant earthquake in Kansas was incredibly rare. So what changed? The story starts to shift dramatically around 2013. Suddenly, seismographs in Kansas started lighting up. The number of earthquakes with a magnitude of 3.0 or greater, strong enough to be felt, skyrocketed. We went from having maybe one or two of these a year to hundreds. In 2015, Kansas recorded over 800 felt earthquakes. That's a massive jump. So did Kansas suddenly drift over a new tectonic plate boundary? Did a secret volcano pop up under Wichita? The answer is no, and it's something far more connected to our modern world. The overwhelming scientific consensus points to a phenomenon called induced seismicity. That's a fancy term for earthquakes caused by human activity. So what human activity are we talking about? It's directly linked to the oil and gas industry, specifically a process called wastewater disposal. Let me break it down. When companies extract oil and gas, a lot of other stuff comes up from the ground with it. We're talking about super salty ancient seawater, often mixed with chemicals used in the extraction process. This stuff is called wastewater, or brine. You can't just dump it in a river. It's way too toxic and salty. So the standard industry-approved method for getting rid of it is to pump it deep underground into what are called disposal wells. These wells push the wastewater thousands of feet down into porous rock layers, locking it away far below our freshwater aquifers. For a long time, this was seen as a safe and permanent solution. But here's the catch. Deep beneath Kansas, there are ancient, hidden fault lines. These are cracks in the Earth's basement rock that have been sitting there, mostly inactive, for millions of years. They're under a lot of natural stress, but the friction between the two sides of the fault keeps them locked in place. Think of it like trying to slide two rough pieces of sandpaper against each other. It takes a lot of force to get them to move. Now imagine what happens when you inject massive volumes of high-pressure liquid right next to one of these sleeping faults. The water seeps into the cracks and pores of the rock. It acts like a lubricant. Suddenly, that friction holding the fault together is dramatically reduced. It's like pouring oil between those two pieces of sandpaper. They can now slip past each other with much less force. This is exactly what scientists believe happened in Kansas. The huge increase in wastewater disposal, particularly from fracking operations in both Kansas and neighboring Oklahoma, essentially woke up these ancient faults. The injected fluids increased the pore pressure in the rocks, lubricating the faults and allowing them to slip, releasing energy in the form of earthquakes. It is important to clarify. It's not the fracking itself that causes most of these quakes, but the disposal of the wastewater that is a byproduct of the process. So while Yellowstone's quakes are the Earth naturally letting off steam, the Kansas quakes were, in large part, an unintended consequence of our own industrial activities. We were essentially giving these old faults the little push they needed to move. You might be wondering, how do we know this is the cause? Well, the evidence is pretty compelling. Scientists mapped the locations of the new earthquakes, and they lined up almost perfectly with the locations of high-volume wastewater disposal wells. The timing was also a dead giveaway. The surge in earthquakes directly followed the surge in wastewater injection volumes. When one went up, the other followed. It's a classic case of correlation and causation that has been studied and confirmed by the U.S. Geological Survey and numerous university researchers. They've even done complex modeling that shows how pressure from an injection well can travel through the rock and trigger a fault miles away, sometimes months or even years later. The biggest of these induced quakes in the region actually happened just across the border in Pawnee, Oklahoma, in 2016. It was a magnitude 5.8, one of the strongest earthquakes ever recorded in the central United States. It caused significant damage and was felt across several states all the way to Kansas. This event was a major wake-up call. It proved that induced seismicity wasn't just about small, harmless rumbles. It could cause serious, damaging earthquakes in areas that were completely unprepared for them. Buildings in places like Kansas and Oklahoma aren't typically built to the same earthquake-resistant standards as those in California, because historically, they never had to be. So, what happened next? Faced with this growing problem, state regulators, like the Kansas Corporation Commission, had to act. They couldn't just let the ground keep shaking. Starting around 2015, they implemented new rules. They created areas of interest, or seismic concern zones, around the earthquake hotspots. Within these zones, they drastically reduced the amount of wastewater that companies were allowed to inject. In some cases, they put a cap on the total volume. In others, they limited the daily injection rates. The goal was to reduce the pressure being put on those underground faults and give them a chance to stabilize. And guess what? It worked. After the regulations were put in place, the number of earthquakes in Kansas began to drop, almost as dramatically as they had risen. It wasn't an overnight fix, but year after year the seismicity has declined. This provided even more powerful evidence that the wastewater injection was the cause. When we turned up the pressure, the earthquakes started. When we turned down the pressure, the earthquakes stopped. It's a pretty clear relationship. While the number of quakes is now much, much lower than it was at its peak, the region is still more seismically active than it was before 2010. It seems that waking up those ancient faults has made them more susceptible to slipping, even with less provocation. So to circle back to our original question, why has Kansas had more quakes than Yellowstone in recent years? It's because we were looking at two different types of earthquakes. Yellowstone has a steady, natural rhythm of tectonic quakes caused by volcanic and plate-shifting forces. Kansas, on the other hand, experienced a temporary massive spike in induced earthquakes, triggered by human industrial activity. The sheer volume of wastewater injection simply caused more faults to slip in a shorter period than what was happening naturally at Yellowstone. Thankfully, through regulation and a better scientific understanding of the problem, the situation in Kansas has been brought under control. It serves as a powerful lesson about the complex and sometimes unexpected ways our actions can impact the planet, even deep beneath our feet. This whole episode has taught us a lot. It's a fascinating case study in geology, engineering, and public policy, all rolled into one. It shows how important it is to monitor and understand the consequences of our industrial processes. What seemed like a perfectly safe solution, disposing of waste deep underground, had an effect nobody anticipated. Now, geologists and engineers are working on better ways to manage this risk, like choosing disposal sites more carefully to avoid known faults and monitoring underground pressure in real time. It's a reminder that the Earth is a complex and dynamic system, and we're still learning about how it all works. Thanks so much for joining me on this deep dive into the shaky story of Kansas. It's pretty wild to think about, right? If you found this interesting and learned something new, do me a huge favor and hit that like button. And if you want to explore more fascinating science stories like this one, make sure you subscribe to the channel and turn on notifications so you do not miss our next video. Got any questions or ideas for a future topic? Drop them in the comments below. I love reading them. Thanks again for watching, and I'll see you in the next one.